Yes. So good morning. In our last class, we have derived mirror equation, and I have told you mirror equation is the relationship between focal length, object distance, and the image distance. And we have proved that 1 by focal length is equals to 1 by object distance plus 1 by image distance. This is the relationship between focal length, object distance, and image distance as far as the spherical mirror is concerned. See, when I say a spherical mirror, it may be a concave mirror or it may also be a convex mirror. This equation holds good for both concave as well as convex mirrors. Concave mirror equation is for convex mirror equation is for this is first thing. And the next thing is, what is the use of this equation? Why do we use this equation? 1 by f is equals to 1 by u plus 1 by v. Why do we need this equation? Why we have derived this equation? We have derived this equation to understand the change in position of the image with respect to change in position of the object. ನಾವು ಮಿರರ್ ಮುಂದ್ಗಡೆ ಇಟ್ಟಿರೋ ಆಬ್ಜೆಕ್ಟ್ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಮಾಡಿದಂಗೆಲ್ಲ ಇಮೇಜ್ ಪೊಸಿಷನ್ ಕೂಡ ಚೇಂಜ್ ಆಗ್ತದೆ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ ಒಳಗೆ. In case of spherical mirrors, if we go on changing the position of the object, the position of the image also changes. How it changes, that can be understood using this equation. We'll do it, right? Try to understand one thing here. If you look at the mirror equation is 1 by f is equals to 1 by u plus 1 by v. Not visible. Invisible. Even now it is not visible. You once go in participants list ಒಳಗೆ ಹೋಗಿ you search for my name. ನಂದು ಆಕ್ಚುಲಿ ಎರಡು ಲಾಗಿನ್ ಇರ್ತವೆ, ಒಂದು ಲ್ಯಾಪ್ಟಾಪ್ ಇಂದ ಮತ್ತೊಂದು ಒಂದು ಲ್ಯಾಪ್ಟಾಪ್ ಇಂದ ಮತ್ತು ಇನ್ನೊಂದು ಮೊಬೈಲ್ ಇಂದ, ರೈಟ್? ಹೋಸ್ಟ್ ಕ್ಯಾಮ್ರಾ ಓಪನ್ ಮಾಡ್ಕೊಳ್ರಿ. I think it will be visible now. It will be visible. Okay. ನಂದು ಎರಡು ಡಿವೈಸ್ ಇರ್ತವೆ. One is laptop and the another is mobile. Mobile ಓಪನ್ ಮಾಡ್ಕೋಬೇಕು. Okay. Anyway, see, I was telling you, this is the mirror equation which we have derived in our last class. 1 by f is equals to 1 by u plus 1 by v. This equation is applicable for both concave mirror as well as for convex mirrors. You can use this relationship both for concave as well as for convex mirrors. See, once you have derived this, you need to understand why we have derived this equation. What is the necessity of this equation? Try to understand. 1 by f is equals to 1 by u plus 1 by v ಅಂತ derive. After looking at this equation, we feel as in focal length depends upon object distance and image distance. ನಮಗೆ ಅನ್ನಿಸ್ತದೆ focal length depends upon object distance and image distance ಅಂತ. U ಮತ್ತೆ v ನ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ if we change u and v, Suppose u is equal to 1 and v is equal to 1. Say 1 meter, 1 meter of that. Object distance is 1 meter and image distance is also 1 meter. So 1 by f is equal to 1 by u. 1 by u is 1 by 1 plus 1 by v. 1 by v is 1 by 1. So this will be 1 by f is equal to 2. This implies 1 plus 1 is 2. This implies f is equal to 1 by 2. F is equal to 1 by 2. This is the focal length. Is that it? This is the focal length. Or this can be written as 0.5 meter. This is the focal length of the mirror. Suppose if I change the values of u and v, suppose u is made 2 meter and v is made 2 meter. Suppose I change the values of u and v. What happens to the focal length? 1 by f is equals to 1 by 2 plus 1 by 2 of the plus 1 by 2 plus 1 by 2, 1 by u plus 1 by v. So this becomes 1, half plus half is 1. Focal length will be 1 meter, but this is not 2. Mark markige focal length change agala athwa focal length does not depend upon object and the image distances. Remember this. In our last class, we have proved the relationship between focal length and radius of curvature. Focal length is half of the radius of curvature. Focal length depends only upon the radius of curvature of the mirror. Focal length depends only upon the radius of. Just a minute. Can you hear now? You are also sorry go ahead. Is it okay now? Yes. Yes. So I was telling you, focal length does not depend upon object distance and image distance. Focal length just depends upon the radius of curvature of the mirror. F is equal to R by 8. This is the relationship for focal length and radius of curvature. We need to understand focal length depends only upon the radius of curvature of the mirror. ಈ equation ಪ್ರಕಾರ focal length ನಮಗೆ ಏನು ಅನಿಸುತ್ತದೆ? Focal length depends upon object distance and image distance ಅನ್ನಿಸುತ್ತದೆ. Actually focal length does not depend upon object distance and image distance. Actually for a given mirror, focal length remains constant. For a given spherical mirror, for a given concave mirror or for a given convex mirror, focal length remains constant. However, if you change the object distance, corresponding with the image distance also changes to keep focal length constant. If you change the object distance, correspondingly image distance changes to keep the focal length constant. Focal length does not depend upon object distance and image distance. Object distance, image distance change ಆಗಲ್ಲ, focal length change ಆಗಲ್ಲ. Object ಮತ್ತು image distance ಹ್ಯಾಕ್ ಚೇಂಜ್ ಆಗ್ತವೆ ಅಂತಂದ್ರೆ object and image distance changes in such a way to keep the focal length constant. See, we'll try to understand this with an example. Suppose the focal length of a mirror is given as say focal length of a mirror is given as 10 centimeter. Let us suppose the focal length of a mirror is 10 centimeter and the object distance is given as say 5 centimeters or even 15 centimeters. Object distance is suppose 15 centimeters. You will be now asked to find out what will be the image distance. What will be the image distance? You know the focal length, you know the object distance. You can calculate the image distance using this formula. See, for a given mirror, focal length always remains constant. What can change is the object and the image distances, and object and image distances change in such a way that they always keep the focal length constant. Focal length should always remain constant, right? So focal length does not depend upon object and the image distances. Is the dependency here whether focal length depends upon object and image distances or not? Question one more question: does focal length of a spherical mirror depend upon object and image distances? Does focal length depend upon object and image distances? Does focal length of a spherical mirror depend upon object and image distances? Depend after the. Does focal length depend upon object and image distances? Focal length does not actually depend upon object and image distances. Instead, focal length depends only upon the radius of curvature of the mirror. For a given spherical mirror, focal length depends only upon radius of curvature and is independent of focal length is independent of object and image distances. Right? If object distance changes, image distance also changes in such a way that focal length is kept constant. Focal length is kept constant. Right? So this is regarding the dependency of focal length on object and the image distances. After all understanding this mirror equation, we will now try to understand the idea of magnification. Once magnification is taught to you, we'll again come back to the mirror equation and try to understand how focal length remains constant when we change object and image distances. Right? We'll understand it again. We'll now try to understand the idea of magnification. Magnification. See, magnification is defined as the ratio of height of the image to the height of the object. Magnification is defined as the ratio of height of the image to the height of the object. See, when we are taking ratio, we are comparing the height of the image with the height of the object. Object height ne compare madadante, image height enagade, whether the size of the image or height of the image has decreased or the height of the image has increased. That we are going to do in magnification. Magnification is defined as the ratio of height of the image to the height of the object. And magnification is represented by small m. Magnification is represented by small m and is defined as the ratio of height of the image. The height of the image is represented as hi divided by height of the object is represented as ho. Magnification is defined as the ratio of height of the image to the height of the object. See, height of the image will be measured in meters or centimeters. Height of the object will also be measured in meters or centimeters. Measurement. Here, meter and meter gets cancelled out. So magnification will not have any unit. Remember this. Magnification will not have any unit because it's the ratio of same two physical quantities. Numerator nagu height, denominator nagu height. This will be measured in meter, and this will be measured in meter. Meter and meter gets cancelled out. This is the idea of magnification. Suppose magnification in some case, say you are dealing with mirrors, you have calculated the magnification produced by a mirror and the magnification has come out to be 2. Suppose magnification 2 bandhude anta ankonಡಿ. What do you understand when magnification is said to be 2? meaning magnification to how to go back to the definition of magnification. Magnification is defined as height of the image to the height of the object. Magnification is defined as height of the image to the height of the object, and that is equal to 2. That is equal to 2. Height of image to height of the object is 2. So, magnification can be written as height of the image to the height of the object, and that is equal to 2 on the. From this, I can write height of the image. See, height of the image can be written as 2 times height of the object. Height of the image can be written as 2 times height of the object. Height of the image is twice the height of the object. However, what do we conclude about the image? Whether the image is magnified or the image is diminished in this case. What do you conclude? Height of the image is twice height of the object. What do you conclude? Whether you conclude that the image is magnified or the image is diminished. What do you conclude? You conclude what? Yes. Image is magnified. Suppose this was the situation. Magnification is 1 by 3 and suppose in some situation the magnification is observed to be equal to 1 by 3. How do you analyze it? How analyze the magnification? When magnification is 1 by 3, define what is magnification. Magnification is defined as height of the image to the height of the object, and it is said to be 1 by 3. So height of the image will be equal to height of the image will be equal to height of the object divided by 3. Height of the image is 1 by 3 times the height of the object. What do you conclude about the nature of the image now? Whether the image is magnified in this case or the image is diminished. Image magnified or diminished at this time. The image is diminished, right? So once you know about magnification, you will be able to decide whether the image is magnified or the image is diminished. ಯಾವಾಗ magnified, ಯಾವಾಗ diminished. If the height of the image is more than height of the object, if the height of the image is more than height of the object, then the image is said to be magnified. Height of the image is greater than height of the object, the image is said to be magnified. And if the height of the image is less than height of the object, the image is said to be diminished. Image is said to be diminished. Right? The conditions necessary. We discuss more on these conditions in the later stages. I hope the idea of magnification is clear at this point. We have a lot more to discuss about magnification. In our discussion on magnification, okay? But is the definition of magnification clear? How to calculate magnification? Is this clear? Magnification is defined as the ratio of height of image to the height of object. And magnification has no units. Remember this. Magnification has no units. Magnification ಯಾವುದೇ units ಇಲ್ಲ. Voice break ಆಗ್ತಿಲ್ಲ. Is my voice breaking? Okay, we'll try to quickly finish off today's discussion. Okay, now we will try to obtain an expression for magnification. We will try to obtain expression for magnification in terms of image and object distance. See, you know, magnification is hi by ho, that is in terms of height of image and height of object. Now we will try to obtain an expression for magnification in terms of image distance and object distance. We can express magnification in terms of image distance and object distance. See how we do it. Suppose this is a concave mirror. This is pole of the mirror. Line passing through center of curvature and the pole of the mirror is called as principal axis. Let us place an object, say AB, beyond the center of curvature. We have placed an object AB beyond the center of curvature. I want to form the image of this object. How many rays are required? How many rays, incident rays of light are required? I need to form the image of this object. How many incident rays are required? 2. I'll consider one ray of light passing parallel to principal axis. A ray of light passing parallel to principal axis. After reflection passes to principal focus. So this point must be the principal focus. And I consider another ray of light to be incident at pole. A ray of light incident at pole gets reflected obeying the laws of reflection. ಎಷ್ಟು angle ನ incident ಆಗಿರುತ್ತೋ ಅಷ್ಟು angle ನ reflect ಆಗ್ತದೆ. This will be the image of this point A. The point A is the image. We'll write it as A dash. ಅಲ್ಲಿ ಯಾರು ಬೇಕು ಬಂದಿರುತ್ತೆ. This is the image A dash B dash. Now we need to obtain an expression for magnification. I have told you magnification is defined as the ratio of height of the image to the height of the object. Height of image to height of object, that gives us magnification. Then how we do it? What does AB represent? Whether it represents height of object or height of image. Object height or image height. AB. Whether it represents height of object or height of image. It represents height of object. A dash B dash represents height of the height of the image. A dash B dash represents height of the image. Next one, Cartesian sign conventions. I have told you the distances measured above the principal axis and perpendicular to it. Distances measured above the principal axis and perpendicular to it are to be taken positive. Distances measured below the principal axis and perpendicular to it are to be taken negative. Correct? Principal axis ಮೇಲ್ಗಡೆಗೆ ಯಾವ distances measure ಮಾಡಿದ್ರು. The principal axis is perpendicular ಆಗಿ measure ಮಾಡಬೇಕು distances. The distances measured above principal axis and perpendicular to it are to be taken positive, and the distances measured below principal axis and perpendicular to it are to be taken negative. ಹಾಗಾದ್ರೆ the height of the object, we'll write this AB as height of the object, and we'll write this A dash B dash as height of the image HI. Whether HO will be positive or negative, height of the object will be positive or negative. Height of the object, distances measured above principal axis and perpendicular. So height of the object must be positive. Clear? Okay, good.
How about the height of the image? Image with principal axis is in this case, the image is formed below the principal axis. Again, the height of the image must be taken positive. Height of the image positive. Principal axis negative. Okay. Ish calculation and convention gottala. ಈ ಮತ್ತೆ ನೆನ್ನೆ ಮಾಡಿದ್ವಲ್ಲ ಮಿರರ್ ಇಕ್ವೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ಡಿರೈವೇಶನ್ ಅದೇ ರೀತಿ ಮಾಡಬೇಕು. Now look at the triangles A B P. Triangle A B P and A dash B dash P. We'll consider the triangles A B P and A dash B dash P. Triangle A B P and triangle A dash B dash P are similar triangles. They both are similar triangles. A B P A dash B dash P. If you have a triangle, you have to choose one. You have to go to A B P and A dash B dash P, right? Because these two triangles have both object as well as image. See, we need to obtain an expression for magnification. And you know that magnification is height of object to height of image to height of object. So we must have object as well as image in the triangles which we consider. So what I have done is I have considered two triangles A, B, P. This triangle has object in it and A dash B dash P. This triangle has got image in it. So from these two triangles I can write A dash B dash divided by, I have told you, in case of similar triangles, the ratio of corresponding sides will always be equal. Ratio of corresponding sides will always be equal. A dash B dash divided by, A dash B dash divided by A dash B dash divided by A dash B dash divided by AB. ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಆ ಎರಡು ಟ್ರಯಾಂಗಲ್ಸ್ ನ ಸಪರೇಟ್ ಆಗಿ ಮಾಡ್ಕೊಳ್ತೀವಿ. A B P A dash B dash P. You can do this. ಈ ರೀತಿ ಟ್ರಯಾಂಗಲ್ಸ್ ಹಾಕಿ ಕೂಡ corresponding sides ಬರೀಬಹುದು. A dash B dash divided by AB is equals to I have told you first image triangle ಬರೀರಿ, next object triangle ಬರೀರಿ ಅಂತ. ಯಾಕಂದ್ರೆ magnification is the ratio of height of image to the height of object. ನ್ಯೂಮರೇಟರ್ ನಾಗ ನಮಗೆ ಇಮೇಜ್ ಬರಬೇಕು, ಡಿನಾಮಿನೇಟರ್ ನಾಗ ಆಬ್ಜೆಕ್ಟ್ ಬರಬೇಕು. ಅದಕ್ಕೆ ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ ಬರೀಬೇಕಾದಾಗ ಪ್ರಾಪರ್ಟಿ ಬರೀಬೇಕಾದಾಗ first you take the image triangle into account and then you write the object triangle, right? So A dash B dash divided by AB is equals to PB dash divided by PB. I have told you to ignore this hypotenuse. Hypotenuse very big, but we do not write that hypotenuse. Can you tell me what is A dash B dash? Can you tell me what is A dash B dash? Whether it is HI or HO with Cartesian sign convention. I need it with Cartesian sign convention. Whether it is plus HI or minus HI, or it is plus HO or minus HO. Thus, A dash B dash is height of image with negative sign because the image is formed below the principal axis. So I have written A dash B dash as minus HI. A dash B dash is written as minus HI divided by AB. AB is height of the object. Positive or negative one? AB. Positive or negative one? So AB is plus HO. We are substituting these, taking into account the Cartesian sign conventions. A dash B dash is written as minus HI and AB is written as plus HO. That is equals to, what is PB dash? What is PB dash? Distance between pole and the position of the image. It must be image distance V plus theta minus theta note. Plus theta minus theta. PB dash. PB dash. Distance between pole and position of the image is image distance V. But whether it is plus V or minus V, that is required. Whether it is plus V or minus V. PB dash. Plus V ಬರ್ತದಾ minus V ಬರ್ತದಾ ನೋಡಿ. It must be minus V. See, here we are measuring distance in a direction opposite to the direction of incident. Distance is measured in the direction opposite to the direction of incident light must be taken as negative. So it must be minus V divided by what is PB? PB, distance between pole and the position of the object. The distance between pole and the position of the object is called as object distance. Distance between pole and position of the object is called as object distance. So PB is U. Correct? Right? PB as U. Correct? PB is U, Allah. PB is minus U. See, we have to measure all the distances from pole and along the principal axis. Pole in the directional measurement of the object. And this is the direction of incident light. You are measuring the distance in a direction opposite to the direction of the incident. So, image distance must be negative. Minus and minus gets cancelled out here. Minus get cancelled out. Minus HI divided by plus HO will be minus HI divided by HO. Minus HI divided by plus HO can be written as minus HI divided by HO. Minus HI divided by HO. That is equals to V by U. That is equals to V by U. See, minus and minus are cancelled out. Right? So that is equals to V by U. I can write the same as even I have my own. I can write this as HI by HO is equals to minus V by U. HI by HO is equals to minus HI by HO is equals to minus V by U. Can you tell me what is HI by HO? Height of image to height of object. What is this ratio called as? Height of image to height of object. What is that ratio called as? The ratio of height of image to the height of object is called as magnification. So I can write HI by HO as M. That is equals to minus V by U. This is the magnification equation in terms of image and the object distances. Magnification is given by minus V by U. And this is true. And this relationship is true for both concave as well as for convex mirrors. True. Magnification can be written as equals to minus V by U. But then only magnification equation we have drawn a ray diagram which is exactly similar to the ray diagram which we have drawn while doing mirror equation. Mirror equation ಮಾಡಬೇಕಾದ್ರೆ ಏನು ray diagram ಮಾಡಬೇಕು ಅದೇ ray diagram ಇಲ್ಲಿ ಹಾಕ್ತೀವಿ. We have considered two triangles A, B, E, A dash, B dash, E. Why we have considered these two triangles? Because these two triangles have object and images in them. A, B, P, A dash, B dash, P. In these two triangles, I have written A dash, B dash divided by AB. A dash, B dash divided by AB is equals to PB dash divided by PB. One day they are you can take. Serena, 5 minutes other. So PB dash divided by PB can be written. If you want, you can draw the separate triangles and you can do it. Right? A dash B dash is nothing but height of the image. According to Cartesian sign conventions, it must be taken negative. So minus HI divided by AB represents height of the object, and according to Cartesian sign convention, it must be taken positive. So A dash B dash is minus HI divided by A is plus HO. That is equal to PB dash, distance between pole and the position of the image, is image distance, and according to coefficients and conventions, it must be negative, minus B, divided by PB is object distance, distance between pole and the position of the object is object distance, and according to coefficients and convention, even it must be negative. Minus and minus get cancelled out here. So it will left out with minus HI by HO is equals to V by U. So we can write HI by HO as minus V by U. HI by HO is M, nothing but magnification. That is equals to minus V by U. This is the expression for magnification in terms of image and object distances. Is this clear? It is clear enough. Is magnification in terms of image and object distance clear? In this note, we will discuss more about magnification in our next class. Right? You must do this derivation in the magnification, expressing magnification. First, we'll discuss about the significance of this negative sign in the next class. I'll tell you about the significance of the magnification, significance of negative sign in the magnification in the next class. ಯಾವಾಗ ಇಮೇಜ್ ಎರೆಕ್ಟ್ ಆಗ್ತದೆ, ಯಾವಾಗ ಇಮೇಜ್ ಇನ್ವರ್ಟೆಡ್ ಆಗ್ತದೆ, ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ. Right? We discuss about the negative sign in our next class. Right? We just go through this derivation today. Then we discuss more about the